So the chem water review. Remember, this is a video, so you don't have to sit there and listen to me talk about something if you already know it. So just skip over stuff until you get to the place where you don't know something, to the objective that you don't know, and then just watch that. Please don't waste your time watching the whole thing if you already know the stuff. Okay, so the structure of an atom, that is protons, neutrons, electrons. So you have to know placement and you have to know charge. So protons are positive, neutrons neutral, electrons negative. In the nucleus we have protons and neutrons all scattered in there, just shoved together. So nucleus equals protons and neutrons. On the outside, in orbitals, we have electrons. So that's carbon. We have electrons orbiting the nucleus. And then this certain shell right here is called the valence shell. Valence electrons are on the outermost shell. That's basically it for the structure of an atom. Okay, so we need to do atom slash element, and we need to do molecule slash compound. So this, that's an atom. This is an element. So the atom is the actual thing made up of the protons and the neutrons and the electrons. It's an actual piece of matter. An element is the category of the atom, and again, remember that it's defined by the atomic number. Okay. Now's as good a time as any. As far as the element, what it looks like here, this is the atomic number, which is number of protons. This is the atomic mass, or sometimes it's called the molecular weight, or the mass number, which is the number of protons plus the number of neutrons, which means it's the mass of the nucleus. Because what it really is the mass of the entire atom, but electrons, we don't consider to weigh anything. Okay, so that's atom and element. The element's the category of the atom. So if you ever see something about made up of one type of the substance, it's made of one type of atom, all the same, that's probably going to be element. If it's talking about some kind of matter, that's an atom. So molecule versus compound. Molecule is two or more of the same element together. So that is H2 into what else? O2. It doesn't just have to be 2, but I can't think of anything that's 3 right now. But anything that has more than one of the same element is going to be a molecule. Anything that has different elements in it is a compound. So that's going to be something like glucose, because we have 1, 2, 3 3 different elements all bonded together. Or maybe like ammonia, that's a compound, because we have nitrogen and we have hydrogen. Okay, so 2, 2, how an atom's electron configuration affects the type of bonds. All that really means is, I don't know why I drew a C. Maybe let's do oxygen. Okay, 1, 2. It has 6 valence electrons. 3, 4, all by itself. 5, 6. Okay, so what you need to know is how many bonds is oxygen going to form? So you need to remember that the magic number is 8. And so that means if I have 6 in the valence, that means I have 2 holes there, and that means I'm going to form 2 more bonds. I'm going to bring in 2 electrons somehow. Okay, so 2, 3. Explain basic chemical bonds and the type of compounds formed. Cool, so that's just covalent ionic. So a covalent bond shares electrons. An ionic bond is a bond between 2 ions. So that covalent would look like, what's something besides water that we can do? Maybe CH4, carbon and 4 H's. So we have 1, 2, 3, 4. And then we have hydrogen, which, remember, hydrogen has 1 electron. So this is covalent, and we know that because these electrons are clearly being shared right here. The orbitals are together, stuff like that. An ionic bond means that you have 2 ions. So you have hydrogen, which normally has 1 electron, but what happens a lot, because it's by himself, he doesn't have a partner, is this electron leaves. So you have hydrogen, which is now down 1 electron, which means it has a positive charge. And then say we did fluorine, which is just like chlorine. 3, 4, 5. It looks like this. Okay, so that's how fluorine normally looks, but again, because this is unpaired right here, what's going to happen is whenever it's in solution, somehow it's going to get an electron, an extra electron, and that means that it's going to have a negative charge. Okay, this fluorine it was not absolutely necessary for this fluorine to get this extra electron from hydrogen. That's not what's happening. Okay, it just has the extra electron already, so it has this negative charge. So that means if we have a positive and a negative, that's going to form an attraction and a bond between the positive and the negative, and that's going to be an ionic bond. Okay. So composition and structure of molecular formulas, that is this. So if I have 12 glucoses, you need to know that this is the coefficient. You need to know that there are 12 times 6 atoms of carbon, which is 72. Okay, you need to know then that it's 12 times 12 to find out how many hydrogen atoms there are. That's 144. Okay, and then there's 72 atoms of oxygen. You also need to know that in this compound right here, you have 3 elements. Okay, so 2, 5. This is a big one. Okay, properties of water. The first one is hydrogen bonding and polarity. Alright, so remember that water, if I just draw the oxygen right now, and now it's water. This bond right here and this bond are both covalent. They're sharing the electrons, but oxygen holds electrons more often. So that means that the oxygen side of the molecule is partially negative because the electrons are over here more often. Even these electrons right here are closer to the oxygen than they are to the hydrogen. Even though they're still technically sharing, they're still technically both holding on, the oxygen's being greedy. So that means you have the partial negative up here and the partial positive down here. So polarity is unequal sharing of electrons that makes the compound a partially charged compound. Okay, so polarity is important when you start to think about if you had another water molecule. So let's say you had another one right here. It's the hydrogen, oxygen. That would make this the partial positive, this the partial negative. And what you have right here in between the partial positive and the partial negative, that is your hydrogen bond. Okay, so since it is between a partial charge, it is considered a bond with, what are those? Apostrophes around it. So it's very weak. And it's able to be broken with something like a paper clip on the surface of water. Okay, so the hydrogen bonds hold together the water. Okay, so hydrogen bonds happen because water is polar. Water is polar because oxygen is greedy with the electrons. So it's kind of like a domino effect. Oxygen is greedy with its electrons, so that means water is polar. Because water is polar, it's going to partially attract to itself. And when it partially attracts to itself, that's called a hydrogen bond. Then we give special names to the things that water does, mostly because of these hydrogen bonds and because of polarity. So, cohesive behavior. That is cohesion. That's supposed to be an S right there. Cohesion. That is water sticking to water. And that is happening because of hydrogen bonds. Because of hydrogen bonds. Okay? That's in contrast to adhesion, which is water sticking to other stuff. So that is like water sticking to, I don't know, a paper towel, for instance. Or water sticking to a plant root. Or water sticking to the side of a beaker, making the meniscus, making the water go up on the sides like that instead of just going straight across. Cohesion is what happens when you have a penny and the water falls over the side like that, like a muffin. This right here is happening because water's holding on to water. Okay. So that's polarity, hydrogen bonds, cohesion, adhesion. Ability to moderate temperature. That just means that this is actually as a result of water's covalent bonds. That just means that as you put heat into water, it has a really extreme ability to absorb it. So that's why places on the coast, like Florida, stay warm during the winter, because during the summer, water in the ocean absorbs all the heat, and during the winter, when the air gets colder than the water, the heat slowly works its way out during the winter. So it stays a little bit warmer. As opposed to somewhere like Arizona, that's right in the middle of, there's no water around it. It gets super cold and super hot. Okay. Expansion upon freezing. That one's pretty cool. Okay. Because of water's polarity and its hydrogen bonds that it forms with itself, when the water freezes, it ends up making this formation, always, that looks like this. As you can see, I'm putting the partial positives are attracting to the partial negatives. Okay. So normally what happens when you change from a liquid to a solid is all the molecules stop moving around like crazy, like this, and they get closer together because they're not moving anymore. But what water does is, because of these hydrogen bonds that are forming, they have to arrange in a pattern like this, where they're kind of in diamonds or squares, because the partial positive ends want to be next to a partial negative end, and vice versa. So if this water was turned around to where the negative was right here, it would space out. So as this water freezes, what happens is it ends up spreading out because of the hydrogen bonds. So this means that when water freezes, it spreads out, and that means it's less dense, which means ice floats. And that is not normal. Normally, when they stop moving around so much, they just get packed in close to each other because they have stopped moving. They're only far apart when they're gas. But with water, when they're gas, they're able to get right up next to each other because they're moving so often. So that's the reason why you have icebergs floating at the top of the ocean. That's the reason why you have ice cubes floating in your drink. So it's pretty very unique for water to be doing that. And there's one more, which is versatility as a solvent. Just basically polar things dissolve other polar things. It's like we talked about with a magnet and a rubber band. A magnet is going to want to hang out with a magnet and not a rubber band, right? So this is the reason why oil and water do not mix, because oil is non-polar, water is polar. But a lot of things are polar. So polar or ionic is going to dissolve in water. So if I have sodium chloride like this, ionic bond, and then I have water in there, which is partial negative, partial positive. This partial negative is going to kind of attach to the partial positive, and those could start interacting, be kind of bonded. The same with the chlorine and the partial positive up here. So if you're ever separating up the ions, that means it's dissolving. But that's what you need to know. Polar things dissolve polar things, not nonpolar things. And nonpolar things dissolve nonpolar things. So oil would dissolve in oil, but not in water. That's not too important right now. Okay, so the last one is pH. So water, H2O. We know it's covalent, but we also know that it is polar covalent. And that means that these electrons are being held more often by the oxygen. Okay, so let me just finish drawing the whole thing. There we go. So occasionally, what happens is this hydrogen right here, it's not going to let me do it. Let's try again. Okay, so we have these two electrons. They're being held more by oxygen than they are held by hydrogen. So the hydrogen's there. Sometimes what happens is this. It leaves. This hydrogen just gets pulled away. Maybe by something negative like chlorine, it just gets pulled away. Okay, so at this point we have OH and we have H. This hydrogen has 1 proton, 0 electrons, so it has an overall charge of +1. So that's H+. This OH has oxygen and hydrogen. So oxygen has 8 protons. Hydrogen has 1 proton. So it has 9 positive charges. And if we count the electrons, it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Electrons, negative charges. So that means it has an overall charge of -1. So we say OH minus. Okay. So water starts acting differently right here. It turns into ions, which is weird. And if you have a solution that has water in it and it breaks down into hydrogen ions and hydroxyl ions, then it becomes acidic or basic. So if you have more of these, more hydrogen, it's considered to be acidic. If you have more hydroxyls, that's considered to be basic. I don't know really why they chose those words. Okay, so questions on this are always going to be like, as the hydrogen ion concentration increases, is that acidic or basic? And you would say, oh, it's acidic. Okay. Then we have the pH scale, which goes from 0 to 14, has 7 in the middle. I did this backwards. Fantastic. So hydrogen ions are considered acidic. Whoa, that was weird. The way that the math works, you don't really have to know. You'll learn about that in chemistry, but if you have a bunch of hydrogen ions, you're considered an acid, and you are said to have a low pH. Low pH. This is a high pH. Oops. Anywhere from 7 to 14 is considered a high pH. Capital H. And that's a base. Okay, that's basically everything that you need to know. So just let me know before school tomorrow if you have any more questions.